Being able to manipulate algebraic fractions. Again, another key skill that's really important for this course. Always factorise first. It does not matter what you're doing with algebraic fractions. If you're going to manipulate them, somehow factorise it first. Going to make life a lot easier in the long run. So the first thing we do is factorise. Then, very hard to write this in words, so I just put a picture of the parentheses there. When you go cancelling, only cancel complete parentheses or complete factors, not bits of them. People go crazy when they're cancelling. Oh, there's next, get rid of them. No, got to be the complete factors, got to be the same if you're going to cancel it. Well, this one here, there's only one term on top and bottom, so obviously there's no factorising to be done, but we're looking for things that are similar that we can cancel. We've got a cubed and an a, so obviously the a can go into a cubed, give us a squared. We've got b squareds and b cubes and so on and so on. And I guess that's the simplest type of algebraic fraction question that we see when we start doing these sorts of things. Trust me, after a while, this particular fraction, when we get onto a topic later in the year, parametrics, you'll be sick of seeing this particular fraction. It does come up a lot. But let's factorise it, because of course that would be the first thing we do. On the top, there's a common factor of a, bottom common factor of 2a. But I notice on the top I've missed another factor, which would be difference of two squares. So the top can be p squared minus q squared, which is p minus q, p plus q. Now I can cancel. The p minus q, that factor, is exactly the same in top and bottom. Bang, we can cancel that. The a can also cancel, and we get p plus q on 2. The average of the parameters, which of course you have no idea what I'm talking about at the moment, but once we do parametrics you'll understand what I mean by that. Alright, multiplication. So when we're multiplying fractions, we have a rule. What's the first thing we do when we multiply fractions? What would be the first, what was it? Factorise, always factorise first. It's the one thing I said, always factorise first. Doesn't matter if it's a multiplication, factorise. If it can't factorise, like the top of the second one, just put parentheses around it. So it's clear that that's a factor. X plus 1 times 1 if you like. Right, let's do it. So x plus 1, best I can do, 3x plus 1. Wonder which one I did first. Which one would you do first? Which one? Yeah, difference of two squares. So what we've got, 3x plus 1, 3x minus 1. Now, not that I want to encourage you to cheat, but the old fudge factor here. Like, I don't know what this is going to factorise to, but if I was going to gamble right now, I'd say there's a pretty good chance that 3x squared plus 2x minus 1 has a factor of 3x minus 1. I don't know, but I just think there's a good chance that's going to be there. And possibly the other factor is x plus 1. Oh, what do you know? It's just the way we tend to set up these questions. We get all these things. Check it. Don't always just go, oh, that's going to be this. But sometimes you can sort of save yourself a bit of thinking time by trying the logically obvious answer and seeing if the logically obvious answer works. And in this case, it did. And now we can have a heck of a good time cancelling. As long as it's in the numerator, one's in the numerator, one's in the denominator. Does not have to be in the same fraction. Right? So the 3x minus 1 will cancel with this 3x minus 1, and the x plus 1 will cancel with the x plus 1, and everything. In fact, they're leaving us just with the number 1. All of that for 1. Division. Oh, well, that's a bit different now. Division of fractions, classic. What do? First thing you do. Thank you. Factorise, of course, doesn't change. Although sometimes we also like to do the old, remember the old invert and multiply? Do it all in one step sort of thing. Because we don't usually divide fractions, it's just a little bit tricky. I mean, you can, but it's easier to turn it into a multiplication because multiplication and division is exactly the same thing. Division is simply multiplying by the reciprocal. That's all division is. And multiplication is easier when it comes to fractions. So we'll do it. We'll multiply it by its reciprocal, invert and multiply. 3a doesn't factorise, neither does the 6a squared on b, but the other two, what have we got? Common factor. of b. Second one. Ooh, that's a perfect square, isn't it? It's in that form. Well, it's 4ab, but you know, a squared, 2ab, b squared. It's got that pattern happening. So I've got a minus 2b squared. That'll cancel a's, 3's, 6's. There we go. We're left with 1 on 2a, a minus 2b. Adding and subtracting, of course, are different. We can't cancel from denominator and numerator for adding and subtracting because, of course, before you can add or subtract fractions, what do you have to make sure is done? You're going to add... Sorry, what was it? Oh, almost. But before you do that, what would you do? Factorise. Because before you can work out what that common denominator is, you need to know what the factors are. So we still factorise first. There we go. So we have a minus 1, a plus 1. I guess the biggest... It's not a mistake, so it's the wrong word to use. I'm not going to say mistake, although I just did. Finding a common denominator, I guess... What people do, and it sometimes makes life difficult, is they simply multiply the two denominators together and go, oh, there's my common factor. Now that works. So it's okay, but it tends to mean you're going to have more work to do later on. How I do it is I just simply say, if it's not there, put it down. Let me explain. So I just start reading from left to right. A, it's not there, so I put it down. A minus 1. A minus 1, it's not there, so I put it down. A minus 1. A, oh, it's already there. I don't need to put it down. A plus 1, if it's not there, put it down. That becomes the simplest denominator, or in fact, using a mathematical term, the lowest common denominator. Right? If it's not there, put it down. Now to work out the numerator, I say, what's different? So I look at the first fraction, it was a minus 1, and I go, what's different? Well, what is different in those two numerators? Right, so that is what I'll multiply the numerator by, whatever is different. So it becomes a plus 1 squared. So not there, put it down. What's different? Okay, so it becomes a plus 1 squared. Minus, now I look at the bottom of the second fraction, a plus 1. What's different? A minus 1. So the second one now becomes a minus 1 squared. Okay, we now have a single fraction, but I cannot cancel yet. Why not? What have I got to do before I cancel? Factorise, because look what's happened to my numerator. It's no longer factorise. I've got an expression of two terms there. So now we factorise the numerator. A plus 1 squared minus a minus 1 squared. Okay. It's a quick way of doing it. And there's a long way of doing it. The long way of doing it, expand the whole thing out on the top. Collect like terms, and I just end up with 4a. The quick way of doing it is to let the pattern of the maths, let that be powerful. Notice what I've got on the top of this one, a perfect square minus a perfect square. And I know perfect squares, and the numbers are the same. It's just one's a plus, one's a minus. So I know that pattern will always be a squared, 2ab, b squared. One's going to be a plus 2ab, one's going to be a minus 2ab. So if I'm subtracting, well, the a squareds are going to go away. The b squareds will go away. I'm going to be left with 2ab minus 2ab. 2ab, which ends up with 4ab. Go back to the original question. A was a, b was 1, 4 times a, 4a. Now, if you're sitting there going, whoa, what? Anytime you're finding yourself making mistakes going from a step to another step, that means you should have put a different step in the middle. So it's okay to try and do these things in your head and come up with 4a. Like, I mean, I've been doing maths for so long now, I can obviously look at that and go, oh yeah, that's the pattern, that's going to be 4a. I know it's going to turn out to be 4a. I don't need that middle step. I've been doing maths for a very long time. But if you try it, And you might get it too, terrific. But if you find yourself making mistakes, then you need to say, okay, I need to put that middle line in. Okay? Because every time you miss a step of working, you're trying to do more up here. And how you stop making silly mistakes is do less and less in each step. Smaller amount of things you do in a step, the less chance of making a mistake. So it's really how comfortable you feel with playing with the patterns and whether you notice them and things like that. What's going to cancel? The A's cancel. So we have 4 on A minus 1, A plus 1. Okay, we have done a multiplication, we have done a division, we have done a subtraction. 3 fractions? What are you trying to do to us? Man, 3 fractions? What's the first thing I'm going to do? Oh, come on. The first thing you're going to do is factorise. Thank you. The answer has not changed all day. All right, the only factorising you can do is that last one. Okay, denominator. If it's not there, put it down. X plus y squared. Right, let's put it down. X minus y squared. Put it down. Oh, x plus y. Well, hang on, is it there or isn't it there? Whenever you're looking at factors, it's the highest power that you want. Think back to prime factors. You always wrote those numbers as the prime number to whatever power. It's always the highest power you can pull out of it. So when I've got x plus y squared and I've got x plus y, square is the higher power. That's the one I will put down. And similar with the x minus y squared, that's the highest power. So that is what I'll put down. What's different? X plus y squared. X minus y squared. Second fraction, what's different? X plus y squared. And the third fraction, what's different? Well, it was only to the power of 1. I want it to the power of 2. So I need to multiply it by another power of 1. So the x plus y, x minus y. Again, I can expand this whole thing out, or I could look at it and go perfect square plus perfect square in this case. So if it's perfect square plus perfect square, what's going to disappear? It's going to be the middle term that disappears this time. So I'm going to be left with 2a squared plus 2b squared. Yep. 2a squared 2 plus 2b squared. But now I'm going to subtract 2 lots of the perfect square. Whoa, let's call them x and y because that's what they are. I've got 2x squared, I've got 2y squared. I'm now going to subtract 2 lots of the difference of 2 squares, which is x squared minus y squared, but it's minus out the front. Minus minus becomes the plus, which means the x squared is going to cancel. I think 4y squared, is that what I should end up with? Okay, there's expanding the whole thing out. And sure enough, cancels down to be 4y squared. There we go. 1D.